Hello, and welcome to another one of my recordings. Through this recording, we're going to essentially cover loops, which is covered in chapters 4 and 5 of your textbook. Looping essentially allows you to repeat um, blocks of code. So up to now, we have not been able to repeat any part of the code. All of our codes have been sequential. And looping allows us essentially to start from a place, repeat a process. Raptor and Python both, you have a looping structure, and that allow you to perform repetition. In pseudocode, we use the word while, which incidentally is the same as how it's used in Python. And from what you see here, every loop will have essentially three parts. We have to have a variable that controls the loop. We call it a loop control variable, although there's nothing magic about this word or this abbreviation. We just made it up. We have a condition to stop the loop because you don't want to have an infinite loop. And we have the change of LCB to avoid an infinite loop. So again, Python uses the word while for looping, and Raptor actually gives you a looping symbol to perform the looping. All right, so let's just go ahead and do a very quick or a short example. Let's say we want to display the numbers, I don't know, let's say 1 through 10 on the screen. Well, to do this, well, the easiest way, I guess, would be to have 10 print statements to do this. But obviously, you can tell that these are the numbers you want to display, and you can definitely see that there's a pattern involved with this, and a loop is what would be ideal to actually pull this through. So, the first thing is an initial variable. We usually use things like C or X. Let's just use X. And I'm just going to use all lowercase. So say X equals to 1. That's my initial value because I want to start at 1. Then I construct my loop. So I say while X is less than or equal to 10. Well, this is my condition. In other words, the process will repeat so long as x is less than or equal to 10. Well, of course, the very first time x is 1, 1 is less than 10. So we're inside the loop. Now in Python, indentation is what tells it to repeat a certain set of statements. So I'll just indent here also. Again, remember this is just pseudocode. And I'll do print X or output X or display X. And right now I just displayed 1. Now, before I end the loop, I will do X equals to X plus 1. Well, why did I increment by 1? Why did I change X by 1? Because I want the pattern, because the requirement of the program was numbers 1 through 10, and this is obviously steps of 1. And I didn't really say what steps, so I should be doing this. Because if I wanted to write the numbers 1 through 10 with steps of 3, then all I have to change is make x equal to x plus 3. All right, so I press enter, and that's it. Now, if we go through this program, or this pseudocode, notice 1 is less than, x is 1, 1 is less than 10, so we execute the loop, which is print x, which is 1. X is now 2, and then again, the indentation implies that you go back and repeat this process. So now we're asking the same question, except x is now 2. So we're asking, is 2 less than or equal to 10? It is, so we print 2, and we increment x by another 1, so x will be 3. Now, as you can see, this process continues. Now, at the end of the loop, of course, I can have more code, but I could do something like this also, right? If I did this, notice the loop displays the numbers 1 through 10, And this print statement displays the most recent value of x, which has to be 11 because that's what caused the loop to terminate. So if I were to write this pseudocode quickly in Python, luckily because this thing looks so much like Python code, I could just copy this. I could go to Python and let's go here. I had some other code in here which I'll show you. I just want to highlight these and go to format and comment it so it won't run. And we'll come back to this nested loop example. So there. So really the only thing you have to add is this colon because that's what happened. That's what you need in Python. So if I ran this code, I expect to get the numbers 1 through 10 because of this loop. And of course I have this extra print statement that prints 11. So let's make sure this works. We run the module. We're going to save it. I get an invalid syntax. And again, this is Python 3.3, which I keep forgetting. So I put the parentheses around there. Again, you worked in pseudocode. Now it's perfectly fine. You actually go in and work in Python. So all you have to do is just add the parentheses x. And let's just do something like, value of x after the loop, just so that you know what you're printing, equals to x. All right, so let's go ahead and run this again, and this should work this time. And notice we got the numbers 1 through 10, and then the value of the x after the loop is 11. Well, again, if you just wanted to display the numbers 1 through 10, that's all you have to do. Now, if I just go in here and change this x to 4, what do you think is going to happen? Well, you'll print 1 because 1 is less than 10, but then x becomes 1 plus 4. So now the next value of x is 5. So 5 is less than 10, so we'll display 5. So far I have 1, 5. The next value of x is going to be 9. The next value of x is going to be 13, and then we end the loop. So we expect to get 1, 5, 9, and then 13 at the end of the loop. And again, if you're working with this, what you need to do is run these things, play what-if games, and make sure that you understand the mechanics of a while loop. So you got 1, 5, 9, and then after the loop is 13. Now this is what we call a pre-test loop because the condition is done at the beginning of the loop. What do you think happens if I make this x equal to 20? Well, x is 20. Is 20 less than or equal to 10? No. So none of these will execute, which means that we're just going to skip all of the code inside the loop and proceed here. So I expect to get the value of x after the loop equals 20. So let's run that code, and you'll notice that's what you get. Okay? So it's quite possible that a loop never terminates. Now, I'm going to go back in here, change this back to 1, and I'm just going to put a comment line right there, meaning that this statement wouldn't be executed. This is referred to as an infinite loop, because notice what happens is that x starts at 1, 1 is less than or equal to 10, it's a true statement, so we print x, which is 1, and then we go back and repeat the process. Well, because x never changes and stays at 1, and 1 is always less than 10, you're going to end up with a whole bunch of 1s displayed on the screen, and it'll never end. So if I press OK, you'll notice that this is all I'm going to get. Now, if I hold down the Control key and press the letter C, I'm hoping that I'll interrupt the Python interpreter and it'll stop the code. So I'll go back and put back my change of the counter variable or the control variable. So again, did I follow the 3 steps of a loop? Let me go back to my Word document. Where is it? Right here. Initial loop counter variable in this case was x. The condition to stop the loop was less than or equal to 10. And just move this over here. And then the change of the loop, LCV, if I don't change this, I'll get in trouble. Now again, if you make this change so that x is always less than 10, you'll get the same infinite loop. So for instance, if I make this minus 4, well, x keeps getting smaller and smaller, and it will always be less than or equal to 10. Again, play what if games, make sure that you understand the process. So before I know it, I've got tons of negative numbers because this value of x keeps reducing by a negative 4. Okay, so this is it. This is really all there is to a loop. Now, what if we wanted to ask the user? Let's go back in here and have write a program. Let's ask the user to enter 5 test scores. Well, because these test and let's say find the average of the test scores. Essentially, all you have to do here is you write a loop that repeats 5 times. Inside the loop, you have an input statement that asks the user for test scores. You have an accumulator step to accumulate the total, and you have an average calculation, which is really total divided by the number of items that you read. So pseudocode for this will look something like this. We need a loop counter, so let's just call this C in this case. So I'll just say C is equal to 1. Let me just make this lowercase. C equals to 1. And then, I know there's 5 test scores, so I'll have to do while C is less than or equal to 5. So the loop repeats 5 times. And in it, the first thing I want to do is I want to get the test score. So I'll get the score. Once I have the score, I'll do a total. So total equals total plus score. That just adds them all up. And then at the end of the loop, did I indent this? I think I did. Again, this is just pseudocode, so it doesn't matter. So at the end of the loop, all I want to do is calculate the average. So I say average equals total divided by 5 because that's how many test scores I had. And then I say print average. Pretty simple. Again, what made you think that to solve a problem like this, you're going to have a loop? Because you have more than one item to read or more than one item to process. So the process is exactly the same. Read, accumulate, read, and accumulate. So because you're repeating while loop or a loop is ideal. So how easy is it, now that you understand this, is to take this and bring it into Python. So I'm just going to go in. Oh, by the way, I will do a Raptor example also, so I'm not leaving that out. So I'm going to do this. Again, I'm just going to highlight all of these and format and comment out the region. And let's see, I just need to add a colon there. And instead of get score, I have to say something like score equals to input, enter the test score, put the space in there. And of course, let's do float because these test scores could be very floating point numbers. So there, looks like I got the score, calculated the total. Now remember with Python or other programming languages, all these variables have to have a value to begin with. So C has a value, that's our loop control variable, but the score gets a value because I'm inputting it. But this total, the very first time through the loop, this total isn't known. Again, this is our accumulator step. Okay, so what do you think a good starting value of total is? Of course, it should be nothing, and what's better than nothing than 0. So there, let's run this thing to see if it asks us for 5 test questions. Move this up a little bit. It says input test score. Let's just put in 100, 90, 80, another 100, and a 50, right? And when I press enter, this thing has read how many times? 1, 2, 3, 4, 5, and now it looks like it just keeps asking me for test questions. So let me go back to the code and ask myself, well, why is this an infinite loop? Well, it's an infinite loop because I forgot the third step of my loop. What was the third step? Increment the loop. C equals to C plus 1. I bet some of you were screaming at me when I ran this thing without this statement. All right, so go back in here. Of course, I have to do a control C because I gotta get rid of this. Now, 5 test scores is too much. Well, let's just go in. I'm just going to do 3 because I don't want to type too many. So I'll do 3. Run. Now it's going to ask me for 3 test scores instead of 5. And so I put 100, put in 90, and put in 80. And notice this is my average. Of course, did I misspell something here? Yeah, test is like that, which doesn't matter. Now, notice how you have C equals to 3. Do you think you can actually ask the user for this number, having an input statement up above? So first ask the user how many test scores they have. You put it in a variable, and then instead of 3, use your variable. I'm sure you can, so I'll leave that up to you. All right, let's go to Raptor. Now, when you open up Raptor, the usual mode is novice, but if you change it to object-oriented, you get a better sense for this looping structure in Raptor. So that's one thing you may have to do. By the way, if you're in object-oriented mode, you can still run all of your other programs, so it doesn't matter, which mode this is in. Okay, so we want to write the exact same program, and just to keep things simple, let's just go back and run the one with that displayed numbers, 1 through 5. So same thing. I need an assignment, so I'll just drag it over here. And let's save this as, I'll just call it 2. And all right, so double click here. My loop counter, I just call it C, make it equal to 1. And that's my loop counter variable or loop control variable. Then I drag the loop condition right over here. And notice there's a loop. It says, hey, so long as this condition is true, repeat the loop. What's the condition? The condition is C less than or equal to 5. Again, I'm just rewriting the code from the pseudocode that I wrote a while back, like here. Of course, this one up to 10. I just decided to make this up to 5, which is perfectly fine. Okay, so we're inside the loop because 1 is less than or equal to 5. So what's the first statement I want to put here? I want to display, so I get my output right there. And what do I want to display? The value of C. And then, again, don't forget the assignment. Don't forget the increment. Otherwise, you get an infinite loop. So C is equal to C plus 1. Press done. Okay, so how does this work? This thing work then? C is 1. There's a loop. Is 1 less than 5? Yes. Display 1. Increment C to 2 and go back. Goes back here. Is 2 less than 5? Yes. Display 2. Add C, make it 3, and so on. So you know this will repeat. Now, of course, I could put another print statement right here and just do it there. This is the end of the loop. I could say at the end of the loop, or actually at the, I guess, the termination of the loop, C is equal to, notice here we use the plus operator and C. Press done. I want to run this. I should be getting 1 through 5 and then 6 at the end. So let's run this thing. And the good thing about the Raptor, of course, is just walks you through the process so you could see what's happening. Python doesn't do that for you. And this thing ended finally. So you got 1 through 5. At the end of the loop, C is equal to 6. Again, this is the exact same program we wrote in Python. Okay, now again, I have posted a working file asking you to write a whole bunch of loops. a whole bunch of program statements. These start from real easy to a little bit more difficult. I will post the answers to these by next week, exactly a week from today. Um, so that would give you time to work on this, and then of course check your answers when you're done. Okay, now one last thing I want to do is the concept of what we call nested loops, which is covered in chapter 5. And essentially, nested loops is nothing but having a loop inside another loop. Notice in this example, I have a while loop, and then I'm doing a whole bunch of stuff, and then one of those statements happens to be another while loop. We call these nested loops because you have a loop within a loop. This is referred to as the outer loop, and then of course, as you might expect, this will be called an inner loop. Now, if I put another loop inside this loop, then this will be the outer loop for this other one. And there is really no limit to how many nesting of loops you can do. And it all depends on the type of program or problem you're trying to solve. So let's go through this without me running this in Python or Raptor. See if we know or we can guess at how this whole process works. If you understand the mechanics of this loop, it'll be a lot easier for you to actually write your own nested loops to do or to solve other problems. And you're going to need nested loops when you get to chapter 5 definitely, and obviously, of course, for this problem right here, I think problem 10 I've asked for writing a nested loop, so that's where you get to practice with that. All right, so loop control variable for the outer loop starts at 1. We check, is 1 less than or equal to 3? Yes, it is. So we print x. So if I was keeping records somewhere on the on the sideline here, I'll just go put a tab in here. I just printed 1. Then it says y equals to 5, and then it checks, is 5 less than or equal to 7? The answer is yes. So you go inside this loop and you print y. And what did we just print? What is the value of y? 5. So I get 5. Then y is equal to y plus 5, which is 5 plus 5, which is 10. Now again, remember, this is a indented block, meaning that as soon as we hit this, we're going to go back to the beginning of this loop. And the value of y now is 10, and we're asking, is 10 less than or equal to 7? Well, it isn't. So you exit this loop. When you exit this loop, where do you go? Well, you go to this statement after the end of that loop, and this one simply says x is equal to x plus 2. So what was the value of x? 1. Now is 3. Now, where are we going to go next? Well, this happened to be at the end of this outer loop, so we're just going to go back all the way to the beginning and look at x, which is now 3. Is 3 less than or equal to 3? It is. So we print x. So on our cheat sheet right here, I want to write 3 because that's the value of x. Y is equal to 5 again. Is 5 less than 7? Yes. What do we print? Y. So that's 5. The value of y is equal to 5 plus 5, which is 10. We go back to the beginning of this loop. 10 less than or equal to 7 is false, so we exit the loop, go here, and x is equal to x plus 2. But what was the last value of x? It was 3. 3 plus 2 is 5. So x is now 5. Well, obviously, we're just going to go back all the way to here and begin the outer loop. Except here, 5 less than or equal to 3, the condition is false, so the program exits. Or not the program exits, the loop exits. So we're going to go all the way to here. Remember, 5 is not less than or equal to 3, it's bigger than 3. So it says print x. What am I going to print? X. What's the value of x? 5. What's the value of y? What's stored in y? It had to be 10, I believe. Now, again, if you're doing this on a piece of paper, you might benefit by just keeping track of all these intermediate variables, so you could properly follow the, a nested loop in this case. Okay, so if I ran this code in Python or Raptor, I expect to get the numbers 1, 5, 3, 5, 5, and 10. And Python, if you've noticed, and even Raptor by default, the print statements go to the next line. So you expect to get 1 on one line, 5 on the next line, and so on. I'll show you quickly how to do this so to get everything on the same line. But let's go in, and I've already written this program. I'm going to comment this code right there. That way it won't run again. And this is the code that I had before. So I'm just going to highlight and uncomment like so. And now, is this the same as what we just did? Let's double check. X is 1, while X is less than or equal to 3, print X. I put parentheses around it so it will work in Python. Y is 5. Yep, same exact code. So I'm going to run this, and I expect to get 1, 5, 3, 5, 5, 1, 0. Let's run the module, press OK. So you got 1, 5, 3, 5, and at the end of the loop, you get 5 and 10. That's essentially it. Now, if you go in here, now the default in Python with a print statement is if you just have a print statement, it will always go to the next line when it's done. One trick you could do is to do something like this, where we say and equals essentially a blank space. So I'm going to just do that, and I'm going to go here and do and equals to blank blank. Again, I'm not doing any changes to the logic of the code. It's just that I'm saying when you print this, I want you to essentially stay on the same line before you print this. So let's run this and see what happens. Notice it says 1, 5, 3, 5. At the end, X is 5 and Y is 10. Well, how about I put a space between the 1 and the 5? How about if I go in here and put a space right there and run it again? Looks like I got spaces in there. And again, it's really not that big of a deal to, at least for this programming class, for this intro to programming class, to master how Python displays output on the screen. What's really important is for you to be able to, one, understand the mechanics of loops, and two, of course, to be able to write programs that use nested loops. Okay, well, I hope this was helpful. Again, don't forget to go to your class module. I believe I put this under the assignments or the class discussions module. And I think we also make this extra credit. So if you, submit any code, you get some extra credit. By the way, extra credit is really not that much extra credit. So if you're on the borderline, want to assign final grades, this might help. So the incentive is really for you to actually do these things to learn. But yeah, even if you do 2 or 3 of these, go ahead and submit by the due date, which is available when you log into Canvas to the course. But try to do these, and if I were you, I start with a pseudocode first. Make sure the pseudocode works on a piece of paper, and then convert it to Python or Raptor. Okay, I didn't get time to actually implement this code that we just did in Raptor, but I hope you can actually take this and convert it to Raptor, because it's nothing but dropping another loop inside the loop. So if I just drop this right there, notice I've got another loop. So not a big deal. A loop within a loop is called a nested loop. Again, if you run into problems with this and then you can't do this same problem in Raptor, for those of you who try it, let me know and I'll try to help out. Okay, I'll stop right here. Have a good day or night, depending on when you're viewing this recording. Goodbye.